Dear students, in today's lecture, we are going to derive mirror formula for a convex mirror. Okay, so the image formation due to a convex mirror, it's almost familiar for you people because we had a detailed discussion regarding the mirror formation, image formation due to a spherical mirror in our previous lectures. Okay, so now we are going to derive the mirror formula. All right, so what was mirror formula? Mirror formula was 1 by V plus 1 by U equals 1 by F. This was the formula. Okay, and here we are going to derive this for convex mirror. For concave mirror, in both the cases, like once the image formed was real and once the image formed was virtual, we already had a discussion. Now we are going to do that for convex mirror. So here we need to have only one case, because in this case you know that the image is not going to be a real image, it's going to be a virtual image only. So as what we discussed in the case of concave mirror also, first of all we need to find out those two sets of triangles. Okay, so here my first set of triangle is triangle ABC and triangle A dash B dash C dash. Sorry, not A dash, it's A dash B dash C. You might have got it. I'm just going to create that. Okay. This is that first set of triangle ABC, and here this is the second one. Okay, second one in the sense like this is that second one. Okay, so both has got a common angle, say theta. Fine. So that is how I selected that two sets of triangles. Okay, fine. So this is that first set, set number one. Okay, now set number two. Let's see which is going to be that second set of triangles. That's going to be triangle APB, APB, and triangle A dash B dash B, A dash B dash B. I can show that one. See, if this angle is theta, of course this angle is theta, angle of incidence. Here is angle of reflection, that also has to be theta. And if this is theta, of course this angle is also has to be theta. Okay, so that is the first thing that you must know. Now see, these are the two sets of triangle. Triangle number one and triangle number two. The two set of triangles, because here this is theta, this one also theta. So here that's also theta. So that is the second two sets of triangles. All right. So we had that two sets of triangles, and you know that these two sets are similar triangles, and these two are similar triangles, as well as these two are similar triangles. Now we are going to go ahead with our derivation part. All right, so let us consider first of all triangle ABC and triangle A dash B dash C. So from this one, ABC and A dash B dash C dash, I can say that AB upon A dash B dash, AB upon A dash B dash should be equals to BC upon B dash C. Let this be equation number one. Okay, now from triangle APB A P B and A dash B dash P, I can say that AP upon A dash B equals BP upon B dash B. Let this be equation number 2. Okay, equation 1 and equation 2. Now what we need to do is, you can see that equation number 1 and equation number 2, it has got the same value for left hand sides, isn't it? So we are in need of this diagram once again. That's why I'm taking a copy over here. Okay, हमें दोबारा चाहिए होंगे. All right. So that's why I'm going to do it once here also. So right hand side of equation number 1, that was BC upon B dash C equals BP upon B dash P. Here identifying those terms that need to be splitted is very important. Out of that, it's very clear, this one BC as well as B dash P, ये दो इक्वेशन आपको स्प्लिट करना है. स्प्लिट क्यों करना है मैं ऑलरेडी आपको बोल चुका हूं. सो ये सॉरी ओके, इसको अभी स्प्लिट नहीं कर. यस, स्प्लिट क्यों करना है, आई कैन टेल यू. जो भी रीडिंग्स P से स्टार्ट नहीं हो रहा है, लाइक इट कुड बी PB, that means object image. Okay, PB dash, that is image distance. This was object distance, this was image distance. Now PF, focus. PC, radius of curvature. So सभी में आप देख सकते हैं P term is there. So इसको स्प्लिट करने की जरूरत नहीं है, आप डायरेक्ट इसमें सब्स्टिट्यूशन कर सकते हैं. बट BC B dash C, इसमें P का टर्म नहीं है. So that is why you need to split these two distance, PC as well as BC as well as B dash C. अब आप देखिए BC is this distance, see from here to here. Okay, so you can split into two, like BP plus PC equals BC. Okay, so from here BC का वैल्यू आपका आ चुका है in terms of P. Okay, in terms of P आ चुका है. Now go into the next part, B dash C. So there what I'm going to do is, see, आप देख सकते हैं, this is what I'm going to take now. What we need is B dash C, that means I'm going to take this distance from here to here. Again you can split into two part. देखिए, that is PB dash PB dash plus B dash C equals PC. From here B dash C equals PC minus PB dash. Okay, so we got our second term, that means B dash C also in terms of P. Okay, so now comes the substitution. Alright, now we are going to substitute these two values. First of all, we are going to substitute the value of BC. So while substituting the value of BC, it's going to be like this. See, आप देख सकते हैं BP plus PC upon B dash C को हम substitute करेंगे, this PC minus P B dash equals bp upon b dash p. Okay, so substitution भी हो गया. Now we need to do the cross multiplication. All right, देखिए, that is bp plus pc into b dash p equals pc minus pb dash into bp. Okay, so now we need to open the bracket, that is bp into b dash p plus pc into b dash p equals pc into bp minus pb dash into bp. Okay, now what you need to do is you need to have the substitution for this bc, pc, b dash p, etc etc etc. Okay, so now let us see इसका सब्स्टिट्यूशन करते वक्त क्या क्या वैल्यू आएंगे. सबसे पहले bp. ओके, आप देख सकते हैं दिस इज दैट bp वैल्यू. bp बोलो तो इट्स टुवर्ड्स लेफ्ट, सी towards left, and that is what u. Okay, so this is going to be minus of u. bp is going to be minus of u into b dash p. This is b dash p towards right, so that's going to be plus v, है ना. तो आप देख सकते हैं, देखिए this was that reading v. All right, plus pc. pc means this is that pc value towards right, and that is equal to 2f, so it's plus 2f into b dash p. Already we had a discussion on b dash p, that is plus v equals pc. Again pc is coming, and you know that it is plus 2f into bp. We already had a discussion on bp, that is minus of u minus of p b dash. We already had a discussion on p b dash, yeah, b dash p. Okay, that is plus v into bp. bp is towards left, we already had a discussion, that is minus of u. So we are now done with the substitution as well. All right, now let us solve this equation. So here this is going to be minus of uv. This will give the value as minus of uv, plus here this is going to be 2 times f into v equals, here this is going to be minus of 2f into u. All right, and here this expression is going to be plus u into v. Okay, plus ub. So rearranging this one, you know that here this can go towards the right. All right, so here this is going to be 2fv on the left equals minus of 2fu plus 2uv. Okay, it's very clear, these two is going to cancel each other. So what we are going to left over here after this is f into v equals f into u plus uv. Okay, now what you need to do is divide this whole expression with uvf, that is fv upon uvf equals fu upon uvf plus uv upon uvf. You know that here this will leave 1 by u, and here this will leave 1 by v, and here I'm sorry. Here this will leave 1 by u. All right, and I think we are missing something. Yes. This negative sign. This, if we forgot to substitute this negative sign over here, so that this is minus, so this should be also equal to minus. Okay, so here 1 by u equals, here this will leave equals to 1 by what minus of 1 by v, plus here this will leave 1 by f. Okay, so here is our final expression, that is 1 by u. I'm taking this towards the left, plus 1 by v equals 1 by f. So here comes the mirror formula for convex mirror. Hope you got it. Dear students, in this lecture we are going to discuss about the linear magnification of a convex mirror. We just had a discussion on the mirror formula. Now we are going to linear magnification. So I'm going to have the same diagram for the mirror formula what we derived. Okay, so here आप देखिए, linear magnification is simply magnification of a spherical mirror. We already had a discussion for a concave mirror. So now it's convex mirror, but the expression is the same, like mathematical expression is the same as here as well. So linear magnification M, that is height of image upon height of object. Okay, and we are going to derive this expression. For that I'm going to take the help of these triangles, that is ABP and A dash B dash P. So मिरर फॉर्मूला डिराइव करते वक्त हमने ऑलरेडी ये बात डिस्कस कर चुका हूं, बट स्टिल आई एम रिपीटिंग, ये दोनों ट्रायंगल सिमिलर ट्रायंगल्स हैं. ओके, सो इधर आप देखिए व्हाट दिस, इस ट्रायंगल से मुझे क्या हेल्प मिलने वाला है. द थिंग इज दैट, सो ओके, कंसीडरिंग दिस ट्रायंगल, लेट मी कम टू दैट फर्स्ट. AB upon A dash B dash, considering these two triangles, AB upon A dash B dash is going to be PB upon PB dash. Okay, I repeat, this is from triangle ABP and triangle A dash B dash P. A dash B dash P. So this relationship came from there. Okay, now what is this AB? AB is this distance. Okay, and that stands for the height of object. Okay, so this is in the upward direction from pole, principal axis upward direction, not from pole, from principal axis in the upward direction. So that is, it has to be plus HO. Okay, now what is this A dash B dash? That is height of image from principal axis in the upward direction. So A dash B dash, we can write it as plus HI, height of image. Now what is this PB? PB is the distance, image distance, sorry, PB is object distance, and you know that you can see it's measured from the pole towards left, from pole towards left it is. So this PB you must consider it as minus of u, because it was object distance. Now next is PB dash. So you can see that that's the image distance, and from pole it is measured towards right, isn't it? So that is why this PB dash, yeah, B dash P, you should mark it as plus V. So I'm going to consider these substitutions here. So AB will become plus HO, A dash B dash become HI, H suffix I, that equal PB will become minus U, PB dash becomes plus V. Okay, now HO upon HI, we know that it is linear magnification. So here comes the expression M, that is linear magnification equals, linear magnification was equal to height of image upon height of object. So this is the reciprocal of M, isn't it? So M equals HI upon HO, that equal to minus of V by U. That gives our final result. Dear students, in this lecture we will discuss how to express linear magnification in terms of U and F. हमने already linear magnification in terms of V and F हमने देख चुका हूँ. We had the expression as small letter m equals minus of V by U. Okay, but here we are going to have in terms of U and F. So how to derive this one is see here linear magnification we are going to have in terms of U and F, isn't it? U and F. So we have normally three terms U, V and F associated to the image formation in a spherical mirror. So here this is object and image, and of course here this is focal length. All right, so here this is U and F. Okay, so what you need to do is in our mirror formula, that is 1 by V plus 1 by U equals 1 by F. In this mirror formula you multiply this entire expression with U because it is in terms of U and F, so that is why you are going to multiply this with U. Okay, so जब हम इसको U से multiply करेंगे, how we can have this expression as the first term is going to be U by V plus the second term is going to be 1 equal to U by F. So here this can be written as U by V equals U by F minus 1. Here this is U by V equals U minus of F upon F. Okay, so if I take the reciprocal of this, V equals to F upon U minus F, not V, it is V by U. V by U equals F upon U minus F. It has to be like this. Okay, and finally we know that linear magnification M equals to minus of V by U. So this expression will turn as F upon F minus U. So this is the expression for linear magnification M in terms of U and F. Next topic is linear magnification in terms of small letter V and small letter F. Okay. We know that linear magnification M means minus of V by U. Alright. So here we are going to find the linear magnification in terms of V and F. So what I am going to do is, देखिए, this is our mirror formula, that is 1 by V plus 1 by U equals 1 by F. इस expression को I am going to multiply with C small letter v, this entire expression. So the very first term is going to be 1 only. The second one, v by u equals v by f. So here this is v by u equals v by f minus 1. So v by u equals v minus f upon f. Okay, we know that linear magnification m equals minus of v by u. Substituting the value of v by u, we will get it as f minus v upon f. Alright, so that is how we can have the expression for linear magnification in terms of f, small letter f and small letter v. Dear students, in this lecture we are going to discuss about refraction. Okay, so definition says the phenomenon of change in path of light as it passes obliquely from one transparent medium to another, that is known as refraction. Okay, let me explain. You're having two transparent medium. Okay, two transparent medium you have. Okay, we are having two transparent medium. Fine. Now the thing is, from medium 1 to medium 2, this is medium 1, okay, and here this is medium 2. Okay, now let this be the path of light in medium 1. I repeat, this is path of light in medium 1. Okay, now the path of light in transparent medium number 1, this is known as incident ray. But it is known as incident ray. Okay, now this yellow line stands for the interface. We can say the separation between the two medium, we can say. Okay, so this is known as the interface between the two medium. All right, now at the point of incidence, I repeat, at the point of incidence of the incident ray and perpendicular to the interface. Okay, I created a normal perpendicular line, so this is known as normal. Okay, now so from medium 1, transparent medium number 1 towards transparent medium number 2, the light is traveling. Okay, now if it was a homogeneous medium, I repeat, if it was a homogeneous medium, it should have continued this path. That means it should have traveled in the same path. Okay, now it was observed that once the light was traveling from transparent medium number 1 to transparent medium number 2, okay, and if the light was traveling obliquely means it will be making an angle theta with respect to the surface which is not equal to 90 degree. Okay, I repeat, it's not equal to 90 degree. That means, see, this is this interface and here this is entering perpendicularly. This must not be the condition. This must not be the condition. Okay, that is theta not equal to 0. Okay, so because we can say that this is the normal if we create, so here the angle that's going to be made with the normal and the incident ray, which is known as angle of incidence I, this must not be equal to what? 90 degree. Angle of incidence must not be equal to 90 degree. That is what this obliquely this particular word stands for. So if this is the condition, instead of traveling in this dotted line, I repeat, instead of traveling in this dotted line, that means traveling without any deviation, it was observed that there was a change in path, say like this, or sometimes like this. Okay, so there was a change in path, and this particular phenomenon is known as what? Refraction. Okay, so this ray, like the path of the light in medium number 1, that was known as incident ray, and the path of light in medium number 2, this could be this, it could be this one or this one. Okay, I will tell you like why I'm giving these two different possibilities. So these two path number 1 and path number 2, इसमें से कोई एक ही होगा, either it will be something like this, otherwise it will be something like this. I mean to say that ये जो path है, इससे towards the normal move करेंगे या away from towards the normal move कर सकते हैं या away from the normal move कर सकते हैं. So here this particular ray which is जिसको हम कहेंगे refracted ray, क्या बोलेंगे? Refracted ray. Refracted ray, it will be either bent towards the normal, otherwise it will be bent away from the normal. Refracted ray means it is the path of the light in medium number 2. मीडियम नंबर 2 में जो लाइट है उसका पाथ को हम रिफ्रैक्टेड रे कहते हैं. ओके, नाउ हम ये देखते हैं कि किस कंडीशन में ये नॉर्मल की तरफ बेंड होंगे और किस कंडीशन में ये जो है नॉर्मल से दूर चला जाएगा. ओके फाइन, आई विल बी नीड ऑफ दिस डायग्राम, इसलिए मैं इसको नीचे ले आ रहा हूं. ओके, सो इस केस में मैंने मीडियम 1 एंड मीडियम 2 दो कैटेगरी डिवाइड किया था, है ना, मीडियम 1 एंड मीडियम 2. ये जो क्लासिफिकेशन के पीछे की क्या रीजन है मैं बता देता हूं. मीडियम 1 एंड मीडियम 2, टू ट्रांसपेरेंट मीडियम. So let the speed of light in medium number 1 be v1 and let the speed of light in medium number 2 be v2. Okay, so if v1 not equal to v2, then only say that they are two different mediums. Otherwise it is going to be the same medium only, then only they are two different mediums you can say. Okay, now if v1 is greater than v2, यानी कि मीडियम 1 में लाइट का स्पीड ज्यादा है और मीडियम 2 में लाइट का स्पीड कम है, देन मीडियम 1 is said to be optically rarer medium, optically rarer one, and medium 2 is said to be optically denser medium. Okay, so जहां पे स्पीड कम है that is going to be optically rarer, और जहां पे जहां पे स्पीड ज्यादा है that is going to be optically rarer, जहां पे स्पीड कम है that is going to be optically denser medium. Okay, so if v1 is greater than v2, that means medium 1 was rarer one, okay, and medium 2 was denser one. Medium 1 was rarer one and medium 2 was denser one. Now I can explain you किस कंडीशन में नॉर्मल के तरफ बेंड होंगे और किस कंडीशन में नॉर्मल से दूर जाएगा. Okay, now let this be the interface between medium 1 and medium 2. Okay, let medium 1 be rarer one and let this be denser one. Okay, and here comes your normal. This is a normal. Okay, now here this is the incident ray. So if the light is traveling from rarer towards denser, so it's traveling towards denser medium. Okay, so अब देखिए towards the denser it was traveling, so the light instead of moving like this, it will bend towards the normal. So here this is the incident ray. Okay, here this is the incident ray and here this is the refracted ray, and it was traveling towards the denser medium, and you can say it is bending towards the normal. It's bending towards the normal. देखिए, it's towards the normal. Alright, and if it is traveling from rarer to denser to rarer one, like this. This was the incident ray, and it should have traveled like this if it was a homogeneous medium. Now you know that it's traveling from denser to rarer, denser to rarer. So towards rarer medium it is moving. Okay, so the ray move should away from the normal. Okay, it should move away from the normal. You can see that like this. So this is a shortcut method that you can memorize, that whether it should move away or towards. Okay, and finally, and if it is traveling normal or along the normal, you can say like this is the interface. Okay, and here this is the incident ray, and normal, of course it should have, this should have, that this should be the direction of normal as well. That means it's going to make an angle theta equal to 0. Okay, so the refracted ray, it will be moving in the same direction. Okay, so you can see that ये 3 diagrams जो है वो वही दिखा रहा है. देखिए, here this is from air to glass. That means here this is rarer, here this is denser. Here this is glass to air. That means denser to rare. In this case, I equal to 0. That means angle of incidence, because it was make normally, isn't it? Angle of incidence is equal to 0. Okay. So finally, इस लेक्चर एंड होते होते मैं एंगल ऑफ इंसिडेंस, एंगल ऑफ रिफ्रैक्शन भी बता देता हूं मैं आपको. फाइन, देखिए, this was the incident ray, that means the path of light in medium number 1. So the angle made by the incident ray with respect to the normal, that is known as angle of incidence. हम angle I से represent किया जाता है. And you can see that this is a refracted ray, this was a normal, and here this was a refracted ray. In this case this was a refracted ray, and in this case here this is a refracted ray. Okay, so the angle made by the refracted ray with respect to the normal, that is R, angle of refraction. Okay, so here this was R, and in this case this is going to be, here this is I, and here this is R. So refracted ray, I already explained, refracted ray means it's the path of light in the second medium, path traveled by the light in second medium, that is known as refracted ray. So here this is I, angle of incidence, that is the angle made by the incident ray with respect to the normal, and angle of refraction means the angle made by the refracted ray with respect to the normal. And the third diagram, which like figure number C, what I was telling is was you can see that incident ray was making an angle theta equal to 0 with respect to the normal. So there you can see that it is traveling without any deviation.